Today we're going to look at everything that's on the 4-2 homework, and it's mostly graphing with a little bit of equations. And honestly, everything that's in it we did last unit.
Wait, is it a new paper?
No, it's in the same packet. It's in the same presentation we did last time. The one that says 4142, kinda. 414, yes, it'll be there. All right. So I skipped a few of the slides on Friday, and today I'm going to finish the ones I missed. So we're starting on, this is slide number 6, so it'd be on probably page 3-ish. So I'm going to teach you guys, oh, this is where the camera is. I'm going to teach you guys 3 ways to graph linear functions. You get to choose which one works best for you. The reason why I'm going to show you 3 ways is because those 3 ways are going to come up later in different sections. Like there's going to be some graphs you want to do one way, some you do another way. So why don't we just learn all 3 ways with linear, so later in the year it'll be easier. Does that make sense? The one is by finding points, and this was also on the test. To graph this function finding points, you simply make your t-chart, right? I'll marker that. Yeah, for me. You make an XY chart, right? I always say with linear, plug in 3 points, because if you're ever measuring and breaking down plywood, if you do 3 measurements per, you get a more accurate depiction of the line. Okay, and it's blue. It's more blue collar that way. So I usually plug in -1, 0, and 1. You can plug in whatever. And what do I plug them into? The function. Bear with me. I don't know what's going on. I am slowly losing my voice. Just makes me sound raspier and cooler, maybe. No. I was cheering too loud. Lions haven't even played yet. Plug in 0. And plug in 1. Any questions on this one? Or you guys feel okay? Good news is, for a linear, this should be the same step every time, right? Because that's what the slope is. That should be the same step every time. It's easy to look at. It makes sense. And then you go graph your points. Are you guys okay if I don't graph this? If you like me to later, I can. But if we have the points, do you think you can match it? Okay. I got my graph paper ready. That's for a different one, though. All right. If that was the only thing that was on the test, would you guys be content? Again, if you like to try this one and then watch the longer video because you want extra practice, by all means do so. This is probably the way you graphed more in high school, was you start with the y-intercept and then use the slope, right? You start with the y-intercept, then use your slope. The reason why this one's kind of neat is because you are actually using the pieces. Like you're understanding what the y-intercept is, it's at 0, and you're understanding that slope is a rate, it's a rise over a run. Okay? So when we graph using this way, again, all these we can do any one of the 3 ways. Okay? When we graph this way, what do we start with? Our y-intercept. Right? So this one, again, that's why I have the graph paper out. If you guys ever want graph paper, there is a whole bunch in that box. Probably for later sections, we do a lot with it. So -7, we start with 1, 2, 3, 4, 5, 6, 7. So we do our y-intercept, and we put a dot there. What's my x value at this point on the graph? What's my x value? 0. Because how do we find y-intercepts? You plug in 0 for x. Keep that in the back of your head. What's my slope of this beast? It's 2/1. I always think of it as a fraction because slope is a rate. It's 2 miles per 1 hour. That's pretty fast for me. My youngest daughter, asked me the other day if she was as fast as the pro football players, and we're like, no. But and her quote was, "Yeah, but I'm pretty fast." She has a lot of confidence. She was also asking the other day, I was driving through town, if she could run as fast as the car was going because she believed she could at the current moment. We were going 25 to 30 miles an hour. And I'm like, you can run like maybe 5 to 10, but you know what? At least she has confidence. She's got lots of confidence. All right, so slope of 2 over 1 says I go up 2, 1, 2, over 1. Up 2, over 1. Up 2, over. Once you have those, oopsie, well, that's good enough. Once you have those 3 points, you're good to go. That's okay if it's a little loose like that. You can just put some trim over it. No one will even tell that you cut that poorly. Sound good? Quick reminder, we went through this on Friday. A good way to check yourself is just a basic understanding of slopes. 2 is a positive, and it's a pretty high slope actually, right? Negatives, when you graph it, they should be going down. Does that make sense? So keep that in the back of your head. So if you're ever given like a multiple choice test question or something like match the graph, use your positives, negatives, fractions, okay? 2 is actually pretty high slope when you're looking at this. I would buy any stock that had a 2 slope. That means it's doubling every x. All right, same thing. You can try another one if you'd like. We talked about it. 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 We did not talk about it. We did that all on Friday. We did that. All right, so we are on slide 18, so it's probably around page 9. All right. So we did that. We can also use our x and y intercepts. This is actually my preferred way to graph things because it works for any type of function, right? Do you remember when we did absolute value? When you graph that, you had to find the x and y intercepts, right? And later on this year, we're going to be dealing with rational and exponential and all these different types of functions. This right here is the same process for everything we do, okay? That's why we're looking at again right now, and we'll look at it again next chat in 2 weeks, and we'll look at it again in 5 weeks. But big thing is we can use our x and y intercepts to graph it and to understand a bunch about it. Quick reminder, put a star by this because it comes up a lot. To find the y-intercept, you plug in 0 for x, and to find the x-intercept, you plug in the 0 for y. And if you want to see a lot of intercepts, watch Dak Prescott play. I'll tell you a story about that later. All right. Are we okay on that? All right. Find your x and y intercept and then graph using that. Okay. So, luckily, you would probably look at this and say, that's the y-intercept, no math required, right? But I'm going to do a little bit of math so that way we get that cemented in our brain. To find our y-intercept, I'm going to say x equals 0, right? So, because see, the intercept you're finding is the letter you're solving for. If you're solving for x, that's your x-intercept. If you solve for y, that's your y-intercept. So I'm going to do y equals negative 1/5 times 0 minus 6, right? So y equals negative 6. Again, didn't have to show any work to do this problem. I'm just showing you the process, right? Trust the process, as Dan Campbell once said. I'm in an FL sort of mood. So the point 0, negative 6 is my y-intercept. The 0 came from x is 0. I solve for my y. Okay? So to find my, I'm going to avoid, guys remind me, I've noticed on my videos, I'm sorry out there, that this is a big blind spot because there's a giant, like, it's super shiny. All right, so for x-intercept, I'm going to say y equals 0. So I'm going to do 0 equals negative 1/5 x minus 6, right? So because I'm solving for x, it's my x-intercept. So I'm going to add a 6 over. How do I get rid of a negative 1/5? I'm going to times by negative 5. Multiply by reciprocals, fraction world. Negative 30 equals x. Well, that's not very helpful. Yeah, that's what it is. So I get the point negative 30, 0. So if I had a giant piece of graph paper, I would graph those 2 points and draw a line in between them. On homeworks or tests and quizzes, a lot of times the graphs will be given, and you'll say, what are the intercepts, vice versa, or you'll just ask for the intercepts. Wow. All right. Are we good on that? Have we ever seen it before? Hey, guess what you can do if you want? You can always try this. Or actually, if you guys ever want to on the examples, if you want to try it and just ask me if you did it right, I would 100% look at it and say yes or no. Sound good? All right. So 3 ways to graph a line. Which one do you have to use? For linear, it doesn't matter. You can actually, for pretty much every problem we're going to do, you can pick which one works for you. Like if you want to find intercepts, that's fine. If you want to find intercept and then slope, that's fine. If you want to do a t-table every time, that works as well for linear. I will say on homework, they will ask what are the x and y intercept. So you do have to do the plugging in dealio. All right, we did that, we did that, we did that. We didn't do that, but I said you could and check it. We did some word problems. We did that. We did not do this. We did at some point this year, but we're going to hit on again. And we're actually almost done with 4-2. What? I might do one more story problem just to get a start on it. Because they show up on 4-1 homework. So I think if we saw another one, it might help us. I want to make sure you guys are successful to do what you need to do. All right. 2 lines are parallel if they have the same slope. They're perpendicular if they're opposite reciprocals. I would rather see, so if one was 1/5, the other would be -5, right? You flip it and negate it. The definition, the proof, if you ever want to do a proof, this is something called, if you ever go on to pre-calc or calc, it's called orthogonal, and 2 lines are orthogonal if their product is -1. AKA, if you multiply those 2 numbers, what do you get? -1. If I multiply these 2, what do I get? -1. If you multiply the 2 slopes, they're perpendicular if they equal -1 when you multiply them. Okay? That's the actual definition for that. But you can say opposite reciprocal is fine too. And if it's not that and it's not that, it's neither. All right. Let's do it. Are they parallel, perpendicular, neither? All right. What's the sloop of this one? 4. The sloop of this one is 4. So they are the same. So that means they are, like I take all the time, a pair of L's. Huh. I'm sorry. Parallel. Same slope. Same slope, different parent function. All right, so 1/3, 3. Now they are flipped, right? Now again, this is not the college algebra way, but it is a way to do it. 3 times 1/3 is 1, not -1. Also, one has to be positive, one has to be negative. So this is what? Neither, right? Neither parallel nor perpendicular. They have no relationship to each other. They just hang out, occasionally meet. All right, -2 1/2. So, are they opposite reciprocals? Yes. Is there a way I can mathematically check? Yep. You don't have to do this. I'm just in my brain. I want some of you might be taking pre-calc next year, and I want you to understand that this is the proof. So that's perpendicular. Are we okay? Are we great? Are we barely making it through on a Monday morning? Well, what do I do if I see this, though? What do you always have to do in order to look at slopes? Get y by itself. Get y by itself, right? Now, there is a trick to this. I alluded to the other day. I'm not going to teach the trick, but if you see it, that's fine. It's always, like this one I know is going to be 5/9. This one I know is going to be -2/8. It's your x over your y. It's the same process every time. Let's see if I was right. So I get -9y equals -5x plus 4. Do I care about that 4? No. Divide by -9. Technically, I'm doing this too, but I don't care. Oh my gosh, I was right, guys. The slope of this one is 5/9. Bet you the slope of this one is going to be a third. Oh, that one's -3, so that was too easy. All right, so this one, subtract my 2x. Divide by 8. I care about that as much as I cared about who won the Giants-Chiefs game last night. So, I watched too much football yesterday, I think. Uh-oh. How do those slopes compare? They're nothing. They're nothing. If you want to do this one and check, they're going to be perpendicular. This one will be perpendicular if you like to try it and see if that's what you got. All right. I think we got two more problems to do, and we might be done. Jeez. Will you stop? All right. So on Friday, we were finding the equations for lines because we'd find the slope between 2 points, right? We'd find this, and then we'd use that y equals, we'd use this equation right here, and we would solve it, correct? We're going to do that again today. The only difference is how are we going to find the slope? We're going to look at another equation and make it either parallel or perpendicular to. This right here, if anyone's giving any thought about possibly taking calculus, is pretty much a majority of what calculus is you're finding the slope of something and then finding the equation for it, okay? If you can do this, you can do Calc 1. I'm dead serious. Calc 1 is way more straightforward than pre-calc even is, I think. So, this equation is what we're going to use. I have a point, x1, y1, right? You guys agree? I'm going to do y minus 1 equals something times x minus my x coordinate. Yeah or no? What am I going to use for a slope? I should read the question first, I guess. It says parallel to this. What's the slope of this beast? That one's 3, right? If it's parallel, what has to be true about my new line? Same. So I plug in we'll do camo colors so no one can see it. right? Same slope. Are we good on that? Is that going to be what I'm allowed to plug in probably on my Moodle homework? No. Distribute that through. Add the 1 over. Ta-da! Questions on that? Yeah, we're just getting our slope from the equation given to us. Uh-oh. Yeah, do you guys want to do one with a fraction or one without a fraction? We should probably do the one with the fraction for practice. This one you can try. Watch the other video to see if you did it right. But let's do this one. It's gross. Big numbers too. Perfect. So I'm going to start with this fun equation right here. This beautiful, wonderful equation. It's the greatest equation. I have an x1, y1. Correct? So I'm going to do y minus 18 equals something times x minus 10. Okay? You guys see where the 10 and 18 came from? So for the slope, it's going to be negative 5, right? Oh, got to read. Perpendicular. So this one slopes negative 5. What do I have to do to make it perpendicular slope? Flip it, and change the sign, right? Flip it and change the sign, right? So the slope of this one is going to be 1/5. Okay? So the number one mistake made whenever I've given tests with this is make sure you read if it's perpendicular or parallel, right? Make sure you read that. Number 2 is make sure you change your signs. -2 positive or +2 negative. All right, distribute. What's 10 divided by 5? Yeah, 2. Add my 18. 1/5 x plus 16. And that is 4/2. We're on the next other packet. We're going to do example 3, and then we'll be done today. There's a problem like this on homework 1. I think it's the last question. Okay? Jiminy Crickets, whatever. All right, so a scientist sees a linear relationship between number of scientific papers published in an institution and the number of grants the institution received. They found that there were 345 papers published at an institution who got 86 grants. Okay? Then they also found another one, 898 papers and 156 grants. So write an equation for number of papers based on received grants. So what do they want equal to it? That's what we need to find first. You see how that's in parentheses? Equation for number of papers published. So we want that to be our outside, and then we're going to have some slope times g plus b. I know that's goofy. I'm just kind of thinking in my head, what's x and what's y? Okay, the years one's easy. Whenever you're dealing with time, time is your x, right? Time is going to be your x, and then whatever you're looking at, it's going to be y. When you're dealing with story problems like this, it's hard to determine what do you want x to be and what do you want y. Since they say number of papers published is what they want to figure out, that's going to be my y. So think about papers as y and grants as x. Okay? Sound good? So I have an x1, y1, right? I have a point. That's one of the points on my graph, correct? I should use that green, doesn't matter. And then I have an x2, y2. That's another, hold on. Joking. Again, make sure you pay attention to which ones you label. So once I have 2 points, now I do this like I did the problems on Friday, right? I have 2 points. I need to find a slope. I need to find room to do this. All right. So to find slope, I'm going to do my change in y. So 898 minus 345 over 156 minus 86. So it's at 545 plus 8, 553. Someone double check me on that. I'm going rogue. And then this one would be what 70? Right? Yeah or no? All right. Gross. Will someone do me a favor and find that as a decimal for me to make our life a lot easier? I'm sorry, what? 7.9? Nice. That's perfect. That will give me a lot less work. Why do you think I don't want to deal with that messy fraction? Because that's going to make life really miserable when we make our equation. I mean, life's already miserable enough right now with us doing this. So I'm going to do this formula, right? Yar. Which point do I choose for my x1, y1? It technically doesn't matter. I usually try to find the smallest point because the smaller the number, the easier it is to work with. Usually. So I'm going to do y minus 345 equals my slope, x minus 86. Yar? Yar or nar? I'm going to need you guys' help. I don't have a calculator. Distribute, like I did with the papers when I was a kid. What's 7.9 times 86? Somebody help me out. Negative 679.4. Right? Oops, that's a minus. And then I add my 345 to both sides. So I get y equals 7.9x minus 334.4, right? Right? Yeah. So now that will not give you full credit on the homework 4.3. Why? What did they want? They want P and G. They wanted P and G. All right, but this one, you don't have any like that exactly like 4-1, but you do have one with years and growth like we did before.
How do you know what the x and the y is? Because I had it flipped.
Because they want the equation for number of papers. So they want papers by itself. So that means papers to y. That's a good question. Yeah, whatever you're writing the equation for is your y, because that's your dependent. That's what you want to know. That's a really good question, because that's going to be the hardest thing to keep track of.